Ohmic resistance. The conductor which obeys Ohm's law, the conductors which obeys Ohm's law are called as ohmic resistance, or we can say resistor, meaning same. Now when we say ohmic, that means here as voltage is increased, current is directly proportional, sometimes also called as linear resistance. So those conductors which obeys Ohm's law are called ohmic resistance or linear resistor. Example, copper, silver, nichrome, aluminium, in fact all metals. Dilute sulfuric acid, in this case resistance is always V upon I, which is constant. In this case resistance is always V upon I, which is constant. Graphically, I versus V is as shown. Draw straight line passing through origin. Non-ohmic resistor. Non-ohmic resistor. The conductors which do not obey the Ohm's law are called as non-ohmic resistor. The conductors which do not obey the Ohm's law are called as non-ohmic resistor or non-linear resistor. Example, LED, that is light emitting diode, solar cell. These are all actually called device, semiconductor device. At higher temperature they are conductor, lower temperature they are insulator. You are going to study in 11th and 12th science. Light emitting diode LED, solar cell, junction diode. Junction diode, comma, transistor. Again, transistor is two junction diode joined together. Transistor, filament of a bulb, because as temperature changes, its resistance changes. So filament of bulb is example of non-linear resistor. Its graph is as shown. V against I graph is a curve. Wherever you want to find resistance, you have to draw tangent at that point. Like if I draw tangent here, then change in Y coordinate. This is delta V and this is delta I. That is called R actually. Can I clear this now? और इधर बाजू में लिख लो डेल्टा V upon delta I is equals to, it is given special name, dynamic resistance. Dynamic means changing at every point. Dynamic resistance. Yes, done.
Yes, sir.
I'm just drawing one diagram for your knowledge purpose. Huh? You tell me which point resistance will be more. This is one curve. V and I ka graph. A is one point, B is one point, C is another point. Where resistance is more? At A or at B or at C? Have you heard in maths that slope is also equals to tangent of angle theta? In maths you have done this? Hello? Hello?
Yes, sir.
This you have done in maths? That
Yeah,
change
sir.
y coordinate upon change in x coordinate, which is slope, is also tan theta. So I want to check whether at A or B or C where resistance is maximum. So if I draw tangent at A, this is the angle made with x-axis. At B, this is angle made. So theta A is more or theta B is more?
A.
A is definitely greater. For C, if I draw one tangent, is it smaller than B or greater than B? I can see theta at A is greater than theta at B is greater than theta at C. That means resistance at A will be greater than resistance at B is greater than resistance at C. So you can expect this type of objective questions. Next, write distinguish between ohmic and non-ohmic resistor. Distinguish between ohmic and non-ohmic resistor. Make two columns. Ohmic resistor, non-ohmic resistor. Yes, you have written the heading.
Yes, sir.
Yes, sir.
First point, what you should write, tell me. Ohmic resistor. It obeys Ohm's law. Here you will write it does not obey Ohm's law. Write down first point. It obeys Ohm's law. And here write down it does not obeys Ohm's law. The VI graph is a straight line passing through origin. VI graph is a straight line passing through origin. The VI graph is a curve. Which may not pass through origin. Third point, the slope of VI graph is same at all points. The slope of VI graph is same at all points. The slope of VI graph is same at all points. Non-ohmic, the slope is different at different points. Next, factors affecting the resistor of conductor. Factors affecting the resistor of conductor. The resistor of a conductor depends upon following four factors. First, length of conductor. See, resistance, practical meaning of it is opposition. So suppose I have to move from Kanjurmarg to Ghatkopar and Kanjur to Dadar, then Kanjur to suppose CST. In which case I have to stop more number of time? Hello?
Yes,
Hello?
sir.
I said if
Yes,
I
sir.
go from Kanjur to Ghatkopar, then I have to stop more number of time, or Kanjur to Dadar, or Kanjur to CST.
Kanjur to CST.
That means when length
CST.
increases, our opposition also increases or not? So it is direct. That means it is directly proportional or inversely proportional.
Not
Directly proportional. So you can say resistor of a conductor is directly proportional to its length. Therefore, are proportional L. Right, first point. Resistance directly proportional to length. Second, thickness or area of cross section of conductor. Thickness or area of cross section of conductor. The resistor of conductor is inversely proportional to the area of cross section of conductor. That means R will decrease if area will increase, and so on. Second point also write down. First 2 points completed.
Yes.
Okay. Third one. Material of conductor. If concentration of electron increases, then resistance decreases. So more free electron, less resistance. Generally we feel opposite. More concentration of electron, it has least resistance. Fourth, dependence on the temperature of conductor. Dependence on the temperature of conductor. In metals, if temperature increases, then random motion of electron will increase. That means their collision will increase. So if collision increases, that means resistance will increase. Whereas in case of material which don't have free electron, if temperature increases, due to heating effect, they will get extra electron. So their resistance will decrease. So sometimes it can increase, sometimes it can decrease depending upon which material we are talking about. So in metals, if temperature increases, then the collision of free electron increases. Hence, resistance increases. Completed?
Yes, sir.
VI graph for a conductor at two temperature. VI graph. The slope of VI graph is called resistance. This is increasing when temperature is increasing. So if temperature T1 is suppose greater than T2, then in this case slope will be greater because resistance is greater. If slope greater, that means it will make larger angle. So if T1 is greater than T2, you can take other way around also. Then if I draw graph, it should make larger angle and other graph should make smaller angle. So this is graph of conductor at two different temperature. First case T1, second case T2. T2 wala line is making smaller angle, T1 wala line will make larger angle. Draw this diagram. So sometimes they will give graph and they will ask which temperature is more. So one which will make large angle will have more resistance, hence its temperature will be more. Can I clear this now?
Yes, sir.
Okay. In school they have completed this chapter. Hello? In school they have completed this chapter or going on?
Going on.
So it's going on.
Which part they are doing? A
So
only or?
actually,
Huh.
so actually today we went back to sound because ours was remaining a little because our sir was on medical leave.
Oh. But you have in the exam this chapter also, I think.
Yeah, we have.
So define specific resistance or resistivity. We know we know that resistance of conductor R is directly proportional to length and inversely proportional to area. So we can say R is some constant into L upon area. This constant is denoted by rho, is actually called as specific resistance, where rho is a constant called as specific resistance. Now I have to define what is specific resistance. Just copy till this, then I'm explaining what the resistance, specific resistance or resistivity can be defined as. Yes, done.
Yes, sir.
Okay. So from this you can write rho equals to R A upon L by cross multiplication. Now if length is 1 meter and area A is 1 meter square, then I can say rho is same as R. So specific resistance, that is rho, is the resistance of wire having unit length and unit area of cross section. Specific resistance is the resistance of the wire having unit length and unit area of cross section. Okay, write this, then we'll check its unit. The resistance unit is ohm, area unit is meter square, and length is meter. So SI unit of specific resistance is ohm meter. So next line, write down. Its SI unit is ohm into meter, symbolically omega m. Its SI unit is ohm meter, symbolically write down omega into m. Yes, done. This also.
Yes, sir.
Next, right. Factors affecting specific resistance. Factors affecting specific resistance. First point. It does not changes by increasing or decreasing length and area. By increasing or decreasing length and area. It is characteristics, property of a material. Hence, changes if material changes. Second point. It depends on material. It depends upon temperature of material. It depends on temperature of material of conductor. It increases with increase in temperature. It increases with increase in temperature in metals and decreases in semiconductor. And decreases in semiconductor. In alloys, in some alloys, it remains constant. In some alloys, it remains constant, such as constantan and manganine. Such as constantan and manganine. Conductivity. Conductivity. The reciprocal of resistivity is called as conductivity. Resistivity is called as conductivity. It is represented by sigma equals to 1 upon 2. That is nothing but rho A upon L, L upon R. Its SI unit is 1 upon ohm into meter. You can also write ohm meter raised to minus 1. Ohm raised to minus 1 is also called Siemens. So Siemens meter raised to minus. Now I'm doing numerical based on this much for theory that we did. Last class I did till I think seven. How many sums? 2 I did. Hello. Last class I have done how many sums? 2.
Sir, four sums.
Fourth was this electric bulb draws 1.2 ampere current at 6 volt.
Yes, sir.
Okay. Just fifth. See, is it same? A car bulb connected to 12-volt battery in your book.
Yes, sir.
So I'm reading this sum. A car bulb connected to 12-volt battery. So V is 12 volt. Draws means it pulls current of 2 ampere when glowing. What is resistance of the bulb? Will the resistance be more or same or less when bulb is glowing? Resistance will be less or more when bulb is not glowing. Sorry. When it is not glowing, temperature is 0, resistance will be less. So by Ohm's law, we know V equals to IR. So R will be V upon I, which is 12 upon 2 equals to 6 ohm. It will be less than 6 ohms when bulb is not glowing. This is the answer of fifth one. Copy fifth properly. Done now? Hello?
Yes, sir.
Next. Calculate the current flowing through the wire. So that means I want I. If resistance is 5 ohm, very simple sum, V is 3 volt. So V you all know, I directly I am writing by Ohm's law, V by R. V is 3, R is 5. So 0.6 ampere. Write down. So I'm clearing this. Next, 7. In an experiment of verification of Ohm's law, find observations. Following observations are made. Draw IV graph and use the following. Draw IV graph and use this graph to find potential difference V when current I is 0.5 ampere. So first we are drawing graph. Potential difference is V, current is I, current is in ampere, potential is in volt. 0.5, 1, 1.5, 2, 2.5, 3, 3.5. 0.5, 1, 1.5, 2, 2.5, 3, 3.5. Current is 0.2, 0.4, 0.6, 0.8 and 1. Draw the graph and then find what is current, what is voltage when current is 5. See, one line you can take for 0.1, 5.1. This is your single line book. You can take, this is origin, this is 0.5, 1. And similarly, you can take 2 centimeter or 1 centimeter for 0.2, 0.4, 0.6, 0.8 and 1. Potential difference is V when current is 0.5. We have to calculate from the graph. Potential difference 0.5, current is 0.2. This is the point. Potential difference 1. Current is 0.4. Potential difference 1.5 and current is 0.6. Potential difference 2 and current is 0.2, 0.6, 0.8. 2.5 and 1. 2.5 and 1. So this is the graph of Vi as per this given information. They want what is potential when current is 0.5 from this graph. When you draw it is clear cut. 0.5 will be at center. So this is 0.5. So this will be my coordinate. Current is 0.5 ampere. Voltage will be between 1 and 1.5. That means 1.25. So when I equals to 0.5 ampere, V equals to 1.25 B part. When current I is passed through the potential difference V is 0.75. V is 0.75 मतलब इसका बीच में आएगा. So definitely current will be 0.3. When V equals to 0.75 volt, I is 0.3 ampere. Third part, resistance R is V upon I. So any voltage and current you can take, corresponding resistance will get. When potential difference is 1, current is 0.4. So 10 upon 4, 2.5 ohms. Yes, any doubt in all the three or all the three you followed? Any three? Hello? Hello?
No, sir.
Okay, draw it and then write the answer. Too much time completed now?
Yes, sir.
Okay. 8. Two wires are of same material. Whenever material is same, that means specific resistance is same. Same length, L1 is L2. Radius of first one is 1 millimeter and second is 2 millimeter. Compare their resistances. So R1 by R2 we have to find and their specific resistance. R is rho length upon A, which is rho length upon pi r square. Area is pi r square. So R1 will be rho 1 L1 upon pi R1 square. R2 rho 2 L2 upon pi R2 square. Dividing equation 1 by 2 we get R1 upon R2 is rho 1 upon rho 2 L1 upon L2 pi R2 square upon pi R1 square. This line followed. Rho 1 upon rho 2 L1 upon L2. Pi is in denominator, so it will become ulta. Pi R2 square upon pi R1 square. Hello?
Yes, sir.
Now rho 1, rho 2 same. Can I cancel? L1, L2 same I can cancel. Pi same I can cancel. So R1 upon R2 is 2 by 1 square. So R1 upon R2 is 4 by 1. So ratio or comparison of resistance is 4 is to 1. Right? Then this rho 1, rho 2 is one liner. Both are same. Therefore it is 1. Here I am writing. Since rho 1 is equals to rho 2, so rho 1 upon rho 2 will be 1. Solve 8th one. Yes, done.
Yes, sir.
One very important point to remember. Suppose this is one wire. I stretch it. If I stretch, what will remain same? This is the wire I stretch. पतला कर दिया इसको थोड़ा. This is first one and this is second one. Now, can you tell me what will remain same? One more example. If this is one container containing liquid of 1 liter, I pour it into another container, same liquid. It takes more height. What is same?
Volume.
Volume. So whenever you stretch a wire may become thin. So if this is area, this is length, new area, new length, but volume of both will remain same. Same way when I compress this patla wire, it will become mota, but total material ka volume will remain same. So just remember, whenever stretched or compressed, always what will remain same? Volume. And volume is area of base into length. So if you can remember this, all problem of wire stretched become very simple for you. Material will not change. So rho will remain same, but volume will get changed. Based on this concept, I am doing sum number 9. A given wire has resistance of 1 ohm. So एक wire है, उसका resistance is 1 ohm. It is stretched so that length is double. New length is double of original. What is new resistance? So I will write like this. When wire is stretched, then volume remains same. Therefore, A1 L1 equals to A2 L2. So A1 upon A2 will be L2 upon L1. A1 upon A2 is L2 upon L1. So wherever I see ratio of area, I will write reciprocal of length. Now R means rho L by A. This means R1 upon R2. Same row will get cancelled. Length L1 upon L2. Area A2 upon A1 because it is inversely proportional. So 1 above, 1 below, 2 below, 2 above. So R1 upon R2 is L1 upon L2 into A2 upon A1 is L1 upon L2. So R1 is 1 upon R2, L2 is 2L1, L2 is 2L1. So L1, 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 L1 cancel. We get R2 is 2 into 2, 4 ohm. So resistance of wire is 4 ohm. Clear? Hello?
Sir, can we use this method? It's like, so we'll resistance ka formula we'll use as rho L upon A, rho
Same,
into L upon A.
same I have.
No, sir, then we can substitute, right? We can take rho 2L upon A upon 2, and then the reciprocal will come and it will become 4 rho 1 upon A, which is basically 4R, which is basically 4 into 1.
But that you wrote only because of this now. Area you wrote as L1 upon L2 because this is valid, no? You skipped 4 lines, na? And then you started like this. Length double, area half. That only you use, na? Hello?
Yes, sir.
So same it is. This is easier to remember. When length is doubled, area becomes half because A and L are inversely proportional to each other. So that's why you are telling L1 upon L2. Here it will become again L1 by L2. So same it will be, na? L1, L1, and below I get 4 times L1. But this way it is easy to remember. Yeah, write down. Oh, sorry. Okay. If done, then please tell me.
Sir, completed.
Okay. Next sum. Okay. A wire of resistance 3 ohm and length original 10 centimeter. Again stretched so that length becomes 30 centimeter. See, orally I know it becomes 1 upon 9 times 9 threes are 27 is the answer. Because length has become thrice. So as you told, it will become square 27. What is new resistance? So when wire is stretched, volume remains constant. AL1 is A2L2. We got this much. We can substitute. Now, last line without putting the values. This is 3 times L1. Or you can actually put the values also. L1 is 10, L2 is 30. L1 is 10, L2 is 30. So this will be 10 30, 10, 30. Therefore, R2 equals to 9 ohm. Answer 9 ohm. Oh, sorry, 3 3s are 9 and R1 is 3, 27 ohm. Same concept. Wire is stretched, volume remains same, so area ka reciprocal is length. You can write directly also, length is 3 times. So area becomes 1/3. Therefore, our final answer will be square. But this is easy to remember and to understand the concept how we got that answer. Eleventh is homework, same problem, tripled wala. 10th you all have done. 11th is homework because it is exactly same. Hello, completed 10th?
Sir.
Huh? 11th
Yes,
is
sir.
exactly same homework. 12th one. What length of wire? What length of wire means L we want to calculate. Whose specific resistance is 1.7 into 10 raised to minus 8 ohm and radius 1 millimeter 10 raised to minus 3 meter equals to 1 millimeter is 1 into 10 raised to minus 3 meter is required so that resistance obtained is of 1 ohm. Resistance is rho L upon area. Area of wire is pi r square. From this length will become r into pi r square upon rho. So length is 1 into pi 3.14. R is 10 raised to minus 3 ka power 2 and rho is 1.7 into 10 raised to minus 8. So length is 3.14 into 10 raised to minus 6 upon 1.7 into 10 raised to minus 8. Therefore, length will become 3.14 in upon 1.7 into 10 raised to 2. That is nothing but L equals to 314 upon 1.7. Then you divide in rough and get the answer. It is coming 184.7 meter. Just try in rough whether it is coming same or not. Yes, done, no? 12th one is also done.
Yes, sir.
So 13th is very simple. I1 is 100, V1 is 0.2 and V2 is 1, I1 is 400 milliampere. Find resistance in each case and account for difference. So resistance R1 in first case, can I write V1 upon I1? Hello?
Yes, sir.
And in second case, we can write R2 is V2 upon I2. So we'll get
Yes,
R1, we'll get R2. Why this difference is coming? You have to explain. This difference is due to when temperature current passes, there is heating effect. Since at higher current, filament gets heated, hence resistance changes. So this is why there is difference in the two resistance value for same material. Hello. So that's all for
Yes, sir.
today. Yeah, next class we'll have same day. This Thursday we are not